and welcome to the 6G Symposium, Shaping Industry and Society Beyond 5G. My name's Alex Lawrence. I'm the Managing Editor of 6G World, and I'll be your host for this opening keynote session. Now, for those of you who don't know 6G World, just briefly, it's a site for news, debates, research and ideas to help the telecoms industry, academia and government navigate successfully from the early days of 5G today through to the end of the decade and the early days of 6G. Now, as well as news, you'll find custom research, monthly webinars, a podcast coming soon, and in September we'll be in the USA for the 6G Symposium there. Now, if you're not already subscribed to our newsletter every 2 weeks, it's free and easy to be kept in the know. Now, in the run-up to this event, I did a quick Google search for 5G 2015. Now, just a few years before commercial launch, all the talk about 5G focused on how smart, programmable networks would enable industrial and enterprise opportunities. 5G was going to be the first G that delivered primarily to the enterprise and B2B market. Now, fast forward to 2021, and 5G is the fastest generation to roll out to consumers, while we have reports like Bearing Point Beyond's that suggest that most enterprises, and especially the smaller ones, may well find 5G too complicated to use. There are better experts than me in this symposium who might venture into the how and the why of this coming about, but clearly there's been a break between the plans and the reality. 5G hasn't been the fit for the world of 2021 that it was intended to be. Now, what has this to do with 6G? Simple. We know that the next 9 or 10 years will see significant changes. 2030 sees us meeting the UN Sustainable Development Goals, I fervently hope, with all of the economic changes that brings as people rework industries to be more sustainable and societies become more inclusive. Now, economies like Indonesia and Egypt are forecast to grow into the top 10 in the world. Now, in the USA, their census office expects immigration to become the biggest source of population growth. And we've all seen how the COVID-19 pandemic has reshaped the ways that people work, socialize, and prioritize around the world. Meanwhile, the telecoms industry is facing its own disruptions, separating network infrastructure from services, private networks, openness, and a push to the edge are reshaping the business and competitive environments in telecoms. To give you an example, earlier this year, I interviewed a company offering global enterprise 5G services as an OTT play. So it's clearly a new world for service providers too. Concepts of cybersecurity are being reimagined to include physical safety and resilience as we increasingly blur the boundaries of online and offline. And let's not forget, in much of the world, we have yet to deliver ubiquitous, affordable, and desirable connectivity. So overall, it's clear that radical change is on the way, and the stakes have never been higher for the telco value chain, for other industries, for societies, and the planet as a whole. Now, succeed and we can play a critical part in delivering on industrial and societal needs globally. And fail and, well, I mean, can we really afford to fail? So how do we get to 2030 with a 6G, whatever that turns out to be, that's fit for the context it comes to market in? Catherine Van Holder, one of our Thursday keynote speakers, would define this as a wicked problem, one where the problem statement and the outcome desired are both not very clearly defined. Now, they do have solutions, but they might not be what any of us think. Only by getting all of the stakeholders together, across regions, across specialisms, and across industries, can we really explore and debate what the outcomes need to be and collaborate on reaching it. And that's why I'm so grateful for you in the audience today, for the 79 expert speakers over the next 3 days, and to the keynote speakers who are coming up in just a few minutes. Today, we'll explore some of the fundamentals of what 6G might be and mean, some of the forces shaping what future telcos will have to be and to do. And tomorrow we'll hear about European and global 6G policy and investment. We'll start to rethink some assumptions about data and privacy and examine how the spectrum and standards worlds are planning to adapt to this. And then on Thursday, we'll explore what that means for the research and innovation process and take some deep dives at the cutting edge of technology, all the way from space to silicon chips. So, 3 housekeeping notes first for your reference. Number 1, you'll see that there's a chat box below your video feed. I'd encourage you to use that to share any questions or comments you have during this session and other ones in the coming days. I can't promise that we'll be able to respond to all of them live, but we will do our best to weave them into conversation where we can. And from a 6G World perspective, just knowing what's on your mind will also let us develop the stories, the research, and the content that's going to be helpful and meaningful to you. Now, second, these sessions are being recorded, and we'll make the videos from the whole event available to every delegate next week through the 6GSymposium site. So if you have a meeting clash or our time zones don't work for you, you have plenty of opportunity to catch up on what you missed. And thirdly, the 6GSymposium didn't just appear out of nowhere. I'd like to thank the University of Surrey's 6G Innovation Centre, the 6G Flagships leadership at the University of Oulu, and Interdigital for their essential support and advice throughout this process. I'd also like to thank 5G-ACIA, the 5GIA, the NGMN, ThinkNet 6G, and Virginia Diodes for their enthusiasm and inputs, which have been incredibly valuable. And with that, let's turn to our two key speakers for this keynote session, focusing on the new industrial revolution and 6G. If 5G was meant to be the enterprise G, what can we learn and what comes next for industry? My first guest, Paul Hart, EVP and General Manager at RF Power for NXP Semiconductors, is based on the west coast of the USA. Now, we're not monsters, so we haven't made Paul get up at 2 a.m. to speak, and we'll hear from him in a video recording. However, Paul and the NXP team have agreed to take any of your questions and create a set of written or video responses on 6G World later this week. So I'd encourage you still to send in your questions. So with that, take it away, please, Paul.
Hello, ladies and gentlemen. My name is Paul Hart. I'm the Executive Vice President and General Manager of Radio Power at NXP. I'm really pleased to be with you here at the 6G Symposium. I would, of course, have loved to have joined you in person, but today we'll be presenting virtually. Today I wanted to speak to you about NXP's vision for 6G. At NXP, we have a long history of innovation in the wireless industry. The company today came together in 2015 through the merger of NXP Semiconductors and Freescale Semiconductors. NXP spun out of Philips in 2006, and Freescale Semiconductors spun out of Motorola in 2004. Both companies have a long history in wireless communications, going all the way back to mobile car radios in the 1940s, through television, the early days of wireless communications, including things like WCDMA, LTE, now 5G. We've had innovations in Wi-Fi, Bluetooth, NFC, and now we're introducing UWB to the world. In every step of this journey, NXP has brought expertise in wireless communications to the market. The history of wireless communications really begins with the need to connect people. Voice-to-voice communications began in the first G era in the 1980s, and they were really about connections between individuals. As we moved into the 90s, we started adding small amounts of data to the network with Edge, and then really in the 3G era, data became key to our wireless experience. Really in the 3G, 4G era, it became about data and connecting the individual with the internet. Wherever the individual needed to be, we were connecting. This network enabled that connection. Data rates increased over that period. Modulation schemes changed. We got to a very high data density per megahertz of spectrum. And fundamentally, we increased the experience everywhere. Today, in the 5G era, we have another step function increase in data rates. This enables much faster communications. We experience that in the world around us, whether it's a millimeter wave connection on a ultra-high data rate Verizon network here in the US, or a sub-6 gigahertz connection using mid-band spectrum globally. The amount of data that's transmitted is increasing exponentially, and the connection experience we're all having is vastly improved. 5G, however, isn't just about data, as the previous sections were, or the previous generations were. It's not just about internet experience for the user. It's also about connecting everything. It's about machine-to-machine connections. It's about automation. It's about using this network in a more instructive manner to improve and make bigger inroads in the world around us. 6G is a vast extension of that. In this instance, it will come with an increase in data rate over 5G, up to 10x. but it will also be about advancing society. It has to be a function of what the network can do for the users rather than creating a pipe and trying to figure out what to do with it. 6G has to be driven by the industry out. Today, we're still very much in the 5G era. We're in the early stages of the 5G supercycle. Today, with release 15, which came out last year, we have enabled standalone 5G networks. We have enabled networks that work with greatly enhanced data rates, enhanced mobile broadband, whether you talk about sub-6 gigahertz deployments globally or you talk about millimeter wave deployments for the highest data rate communications, all those things are enabled and in various forms of deployment around the world. In the next couple of years, with releases 16 and release 17, we're going to introduce in a very significant manner, ultra low latency communications, highly reliable, low latency, point-to-point communications. This is a fantastic step forward, and it's going to enable things like autonomous driving, and it's going to enable industrial automation, and it's going to enable, in the future, advanced AR and VR applications for the network. Release 16 brings in ultra low latency communications. It also brings another number of other features. Release 17 extends those features and combines them with a high data rate. And so think of an ultra low latency application happening in next year with low data rates and extremely high reliability. The future release 17 will enable very high data rate applications also to exist with low latency. So it's really an extension. This network from release 17 forward is really the framework for what we start to think about when we think about 6G. It's the enablement for autonomous driving. It's the enablement for really interactive networks in a variety of new applications we haven't yet conceived. As we look towards 6G, 6G is really, in NXP's mind, 6G is really about ubiquitous connectivity. It's about unlimited connections. It's about building upon the 5G framework in a thoughtful way and layering in a human-like intelligence to the network and a human-like autonomy in the decision-making that happens within the network. It's about everything being connected and everything being accessible and everything being instantly responsive. But all this has to happen in a very purposeful way. And human-like intelligence needs to determine where computations happen. Do they happen at the edge of the network? Do they happen in the cloud? How is data transmitted? Is it transmitted over the 5G pipe, 6G pipe, the Wi-Fi networks, or offloaded in some other manner? And fundamentally, this purposeful network needs to be sustainable. We need to add in layers of complexity. We're going to greatly increase the data rates of transmission, but we need to do this in a sustainable, thoughtful manner. We can't simply allow power consumption to grow exponentially, but we need to rein it in so it's consistent with our view of what the future should be. Finally, a 6G network needs to operate seamlessly. Whether data is transmissioned over the fundamental pipe or it's offloaded, the offloads and the transmissions need to be managed by the network itself in a very thoughtful and purposeful way. 6G really is the combination of the communications, sensing, computing, imaging, and network security for tomorrow. It's all areas of our connected world coming together. When we think about the society and the digital transformation goals, we really are moving from a world in which previous network generations were defined by the specifications. The industry partners got together, the mobile network operators, the equipment manufacturers, the semiconductor manufacturers, got together and thought about what their technology could do. Specs came out of that, and we created a network that enabled broad data transmissions wirelessly. Use cases fell out of that network once it was created, and it was really a metrics-driven approach to a network deployment. As we think about 6G, we need to think about this in a different manner. We need to think about purposeful networks. We need to think about the end applications driving the network requirements and not the other way around. If we take the example of healthcare, in the example of mobile healthcare, there's lots of different applications that can be considered. Everything from health and wellness monitoring, which is done today over smartwatches, et cetera, pacemakers, those sorts of things, all the way to the extreme end of remote surgery. And this range of use cases certainly isn't going to be accomplished through one size-fits-all communication, but rather a range of specifications that come from the application back to the network and really drive the development for the future. All this, of course, needs to be done, coming back to our purposeful and thoughtful and sustainable way, needs to be done in an energy-conscious manner that really enables the goals of tomorrow. I want to also follow up on the concept of safety and security in the networks, because in order for our networks to be trustworthy, in order for us to have confidence in using this vastly integrated and connected network of the future, we need to have confidence that transactions will happen safely. Whether we're talking about low data rate transactions for authentication, for example, a mobile wallet purchase, or you're thinking about very vast data processing tasks that happen in data centers, all these things need to be secure and protected and safe. This is enabled through a scalable compute network and scalable security. Scalable safety is a key tenet of the network of tomorrow. The other big challenge of the network of tomorrow is, of course, managing this inexorable rise of data traffic. We anticipate that data rates will increase, monthly data rates will increase by a factor of 100 in the next decade. And if we look back at the network of today, the 5G network of today, the current network is consuming 2 times the power of the LTE network of 10 years ago. An increase of 100x in data rates cannot drive a subsequent doubling, tripling, or quadrupling of the power consumption of the network and still be consistent with our sustainability goals. If we look towards the UN sustainability goals of the future, they're very much about doing more with less. It's about managing our total resources and driving down the cost and the consumption of our electronics and our interaction with the world around us so that we can have a world for tomorrow. That has to be a central theme in 6G. And as such, we're taking steps at NXP to manage how we can best taking steps at NXP to manage how we can best drive down the power consumption of the overall system. We tend to think of power consumption or energy optimization holistically. In my world, in the radio power world, I tend to think about power consumption from the RF elements in the radio chain. How much power is consumed amplifying a signal for transmission, receiving the signal and getting it ready for processing, and what can I do to drive down power consumption or increase efficiency? Over the last 10 years in the radio access layer, in the RF space, we've come close to doubling the efficiency of the RF elements in a 5G network today in a conventional 2 gigahertz, 3 gigahertz application. However, the power consumption of the total network of the radio layer has increased dramatically. So 10 years ago, in order to transmit an LT signal over 20 megahertz, consuming 1 sector, we would transmit 40 watts of radiated power. That would allow us to cover a range of roughly 25 kilometers in the network for that sector. Today, 10 years later, in a 5G world, sub 6 gigahertz, that bandwidth has increased from 20 megahertz to 200 megahertz. It's brought with it a 10x or greater increase in data rates, but it's also brought with it a 10x increase in the amount of power that needs to be radiated per sector to maintain the same coverage area. If you radiate less power, your cell site reduces, and you need more sites to get the same coverage for a city or a geography. Therefore, increases in efficiency for the radio system has been offset by a much faster increase in bandwidth, and therefore the total consumption of the network has increased. That's how we think about power consumption from an RF perspective. When we think about power consumption from a compute perspective, we think about Moore's law. Today's world, right, in a typical use case today, we can say that for 100 picojoules of energy, I can do 10 multiply operations. For the same amount of energy, I can transmit a fraction of a bit. Therefore, it's more energy efficient to do your computations at the farthest edge of your network versus in a central manner and transmitting data back and forth. If we think about Moore's law of tomorrow, obviously process nodes are going to continue to shrink, and the amount of multiplies we'll be able to do in 100 picojoules of energy will increase by a factor of 10 or more. The amount of power it will take to transmit a bit of energy will not reduce at the same rate as Moore's law. Therefore, going forward, it still will be far more advantageous, in fact, exponentially more advantageous to do your processing at the edge of the network whenever possible. If we think about a small example like voice recognition, today voice recognition is done through over mobile networks, and the voice recognition processing is done in the cloud at a data center at Google, for example. If we were to transition that action from happening at the core to happening at the edge, we would see a transformation in the amount of power that the network consumes. In this example, the consumption at the edge processor, whether it's your phone or your car or the base station itself, would double because it's doing more processing. However, the amount of power needed to transmit data back and forth would reduce dramatically, because no longer are you sending an audio file back to a data center, but you're doing the voice recognition locally, and all you're sending back to the data center is an address, and you're receiving back instructions on how to get to your location. At the same time, we save power at the data center, and this offset in transmitted power versus consumed power at the edge results in a 2x reduction of power in this use case, in this example, in the overall network. Taking a holistic approach to power optimization like that and layering in Moore's law and the things we can do with advanced semiconductor technologies like gallium nitride, for example, in the radio layer, will allow us to create a much more sustainable network for tomorrow. So that brings us to the concept of full dimensional coverage. And what we mean by this is the seamless end-to-end service of the network. 6G is no longer just about the radio access technology, but it's about the thoughtful decision-making, the purposeful network of tomorrow, deciding autonomously whether computations happen at the edge of the network or in the cloud, layering in sensing and actuating so the network is aware and perceptive of the world around it and can thoughtfully make decisions about how best to transmit data in a sustainable way. Full dimensional coverage is also about the ecosystem. It's about industry defining what the network of tomorrow needs to do, how it should be built, and how each industry partner conceives of using this network to expand their own presence. Finally, full dimensional coverage is about the seamless multi-access continuity. It's about the combination of different wireless technologies to create a seamless user experience. At NXP, this seamless multi-access continuity means the combination of your 5G or 6G network of tomorrow with your Wi-Fi and your Bluetooth. It's a combination, it's a linkage of cellular V2X and UWB, and combining these access technologies in a thoughtful way so that the user experiences everything in a clean, easy, straightforward manner. Combining these factors is possible. We have activities underway to drive this together today. It really needs to be a central tenet of the network of tomorrow. And so that brings us finally to the road ahead. As I've mentioned, the road ahead is about industry collaboration. It's about driving a diverse set of goals and partnerships that will create this network of tomorrow. 6G is the convergence of communications, sensing, computing, imaging, control, and security, the central themes of most semiconductor applications in the world today. These things are going to come together in a vibrant ecosystem, and it's supported by supported by a secure and resilient supply chain. It's not about the mobile networks operators and the equipment manufacturers and the semiconductor vendors joining forces and defining the network tomorrow, but it's about the society and the industry as a whole in one voice speaking out of what the network needs to do. If we do that right, if we accomplish this, 6G will truly be a transformational experience for all of society. In conclusion, we're very much at the early stages of the 5G journey. We have a lot of roads ahead of us to build a better connected network of tomorrow, and that is going to lead us into the 6G era, where we layer on top of a fantastically connected 5G network a purposeful and thoughtful human-like intelligence to the network that allows us to create not just a sustainable network of tomorrow, but a network of tomorrow that delivers seamless connections in a thoughtful, manageable, and sustainable way. At NXP, we're investing in every stage of this journey, and we're excited for the road ahead. Thank you.
Brilliant. Many thanks, Paul. Now, my next guest who's here live is Andreas Mueller, the chair of 6G-ACIA, the Alliance for Connected Industries and Automation. Andreas is going to be sharing a talk setting out some key points and ideas and then we'll be able to take the rest of the time in this session for the conversation to explore further. So please do send in your comments and questions. Andreas, I'll hand over to you.
Yeah, thank you very much, Alex, and hello, everyone. Really a great pleasure to be here today. As Alex said, my name is Andreas Mueller. In my day job, I'm responsible for communication and network technology in Bosch Corporate Research. But today I'm here in my capacity as the general chair of 6GSymposium, the 5G Alliance for Connected Industries and Automation. So basically, we are driving 5G for the industrial domain. And let me just bring up my slides, just a second. So yeah, I have the pleasure to also talk a little bit, of course, about 5G and beyond for the industrial IoT. And before I look at the beyond part, I would like to start looking at the 5G part, basically, and outline again, in case you're not so familiar with the industrial domain, what role 5G actually may play in the context of Industry 4.0. And of course, this is the basis to see also what role beyond 5G and at some point also 6G may play here. And if you look at the evolution of mobile communications, and I think that's something we've already seen quite nicely also in the presentation of Paul, there's a major change, of course, with 5G now. So previously, if you look at 1G to 4G, it was all about connecting people and connecting mobile phones in one way or the other. Of course, it changed a little bit. We got higher data rates, we got more services, but at the end of the day, it was really all people-centric. And with 5G, of course, from the very beginning, there was a strong focus on connecting all kinds of things in the Internet of Things. And this enables completely new applications now in areas like manufacturing, but also automotive, agriculture, healthcare, and many other verticals as well. So independent of this, in the industrial domain, we have the developments towards Industry 4.0, the industrial IoT, which started also around 10 years ago. So just this year, we celebrate basically the 10th anniversary of Industry 4.0. And connectivity per se is a key enabling technology for Industry 4.0. So it's all about merging the physical world of production with the virtual world of the IT industry. And of course, connectivity is basically one building block that actually makes this happen and possible. And now it's quite straightforward to bring both developments together, which started independently of each other. That means that we bring 5G to the factory floor. And if we do so, we can lift Industry 4.0 to the next level and achieve unprecedented levels of flexibility, efficiency, productivity, and also ease of use. So that's basically the high-level vision that we have if you look at 5G for the industrial domain. Now, also a couple of words about 6GSymposium. So 6GSymposium has been established basically as the central forum for bringing now all the different stakeholders together on a global scale. And this includes the so-called OT industry, the operational technology industry, so the classical industrial players, factory owners, machine builders, and component providers for industrial automation. And on the other hand, also the ICT industry, of course, with the network operators, the infrastructure vendors, chipset vendors, and so on. And the goal of 6GSymposium is now to jointly drive and shape the developments towards industrial 5G. So this starts with the establishment of a common language. We've already made really very good progress in this respect. It's about making sure that the needs of the industrial domain are probably reflected in standardization and regulation, because many industrial players, even big companies like Bosch and others, have only a very small footprint in 3GPP, for example, in similar organizations. But somehow we have to make sure that the needs and the requirements of the industrial domain are transferred and understood by the relevant standardization bodies. And 6GSymposium provides a shortcut, basically, in this respect. It's also then about developing a joint idea and understanding how we may optimally make use of 5G in the industrial domain. So what can we do with it and how? That we also make sure that 5G seamlessly integrates into the existing environment, because we have a lot of existing communication technologies in place. We are identifying relevant certification and testing needs. So we just kicked off also our testbed framework recently with a number of testbeds already in place, where different members get together to jointly evaluate and validate the performance of 5G in real-world industrial environments. It's a lot about building up the ecosystem getting in touch with other stakeholders from the ecosystem, and of course also a lot about promotion of industrial 5G worldwide, so that we share the knowledge and insights basically that we are building up in 5G ACIA, also with others. And that's one of the reasons, of course, why it's a pleasure to be here at the 6G Symposium today. So 5G ACIA has been established in 2018. Since then, we have really seen a very positive development of our membership. So as of today, we are 85 member organizations. You can see here the logos of the different members. And it's really a good mixture between ICT industry and OT industry. And also we have members from all geographies, basically worldwide. And that's exactly what we wanted to achieve with 5G ACIA. All right, but let's have a look at the current status, basically, of industrial 5G. And I would like to start with the status, basically, of 5G for the classical consumer business. This is where mobile communications is coming from. And this is somehow an evolutionary path, right? So it's still, of course, 5G connects people. 5G can be used to get even faster video downloads and so on. And here I would say we are basically already there, right? So you can buy 5G handsets. The public networks are upgraded to 5G. It's nothing fancy anymore. It's a reality today. That means also here the business potential basically has been unlocked. But on the other hand, we also have to be aware that the additional revenue potential of 5G for the consumer business is very limited. So the ARPU will not really increase. We have seen this also with previous generations of mobile networks. So this is more about securing the existing business from the perspective of the existing ecosystem. Now, if you look at the status quo of industrial 5G, so 5G in the manufacturing and process industries, it's a little bit different because here we are not fully there yet. So there are different reasons for that, which I would like to briefly outline in a couple of seconds. Major reason is that it's not evolutionary, it's really revolutionary. I mean, before we did not really use mobile technology in a factory, maybe with the exception of some very special applications and use cases. But now it's about a more widespread adoption of mobile communications in production environments. And as mentioned before, 5G has the potential to lift Industry 4.0 to the next level and basically to create the factory of the future, which can be quite different from what we have been used in the past. So therefore, it's really revolutionary. That means also it takes a little bit more time. But on the other hand, the perspective is very promising because here it's a completely new market for the entire ICT ecosystem. The potential to really unlock a lot of value, not just by selling services and products to the industrial domain, but also we have a leverage effect. So we can do things in a production, in a factory much, much better. This way gain in efficiency and productivity and so on. And therefore, there's really a lot of value to be unlocked in manufacturing simply because a lot of value is still created in manufacturing. So we are not fully there yet, but there are very big promises. But I think the fact that we are not there yet means there's still quite some work to be done also towards industrial 5G. We should not forget this when talking already about beyond 5G and 6G. And I think the same applies to many other verticals as well. So if you look at the automotive industry, I mean, how many of you have a car that is already equipped with a 5G modem? Maybe not too many. If you look at healthcare, how many hospitals are running on 5G? Also not too many yet. So there's still quite some work to be done to deliver the full 5G promise. But of course, this doesn't mean that it's not okay to start with 6G and looking to 6G. Now, to zoom a little bit in, what are really the reasons why there is still work to be done on the 5G side? Well, one reason is that we started a bit later than in the consumer business. And this is something we will see on the next slide and again. I think now the industrial domain really got aware of the potential of 5G and there's a lot of interest and so on. But it also needs time to really develop the vision and to fully understand what the implications of 5G on the manufacturing business may be yet. Also, of course, some of the key features that really make a difference to the industrial domain come only with 3D16 and then later with 3D17. Also, this is something that Paul has already outlined in his presentation before. So here I'm thinking about ultra-reliable low latency communication with this 1 millisecond latency, the very high reliability, It's about support for time-sensitive networking, which, especially in the manufacturing industry, is a very big and important topic. Also then NR RedCap, which comes with Release 17, which also has quite some promises in the industrial domain. So this is not what we have today with Release 15. It will start with Release 16 and later on enhance with Release 17. And that's also another reason, of course, why we don't see a widespread adoption of industrial 5G. Also, there are special needs apart from these features, and this also still takes time because it's also changes in the entire ecosystem. So I'm thinking about the needs for non-public networks, for instance. There's a lot of interest and many requirements, of course, especially again from the industrial domain. And here it takes some time to come up with new operating and business models for these non-public networks. So we see that also big mobile network operators, for example, are adjusting their business models and so on. And yeah, so this is a very dynamic process, and it simply takes time that we reach a sweet spot, basically, that is then attractive enough for everyone. Also, we still have to undertake this performance validation. So as a factory owner, if you are thinking about running your factory on 5G, you will not just rely on simulation results and so on. So you really want to see the performance in a real world production environment with a lot of metal, with many machines and so on. So that's something that is currently ongoing. I already mentioned the 6GSymposium testbeds, for instance, which is one step towards or in this direction. And we also have different innovation cycles in the ICT industry, in the OT industry. So in the classical consumer business, we are used that everybody buys a new phone every 2 years or so, but it's of course quite different in the manufacturing industry. So typically you don't buy a new robot every 2 years. You have production lines which are in use for 10, 15, sometimes even 20 years or longer. And also the innovation cycles are different. So we need here an alignment between the two different worlds. Also, we have to take into account that the ecosystem for industrial 5G has to grow from scratch. It's nothing that we can build upon like in the consumer business, but really we have to start from scratch. That means we do not only need chipsets and infrastructure components, we need also robots, automated guided vehicles, and so on, integrating 5G. And this again takes simply time. And finally, the last point that I would like to outline here is the chicken egg challenge that we have, which we somehow need to overcome. That means a factory owner has only little incentive to deploy a 5G network in his factory unless there are enough components available that he may use then with the 5G network. So here again, automated guided vehicles, robots, and so on. But it's also the other way around, right? For a provider of components for industrial automation, there is little incentive to offer 5G-based products unless there are enough factory owners being equipped with a 5G network that actually can use those products. And therefore, why it's also, again, very important to bring the entire ecosystem together to make sure that there is a common vision, a common understanding of the potential of industrial 5G, and this then helps to overcome this chicken egg challenge in the long term. All right, if we zoom in a little bit again at the evolution of 5G and especially industrial 5G, so from my perspective, the research on 5G really started with this METIS project in Europe in 2012, when the first visions have been developed and the ecosystem for the first time came together to think about what 5G could be about. So here the discussions also started about bringing in the vertical industries and so on. But then it took like 3 years to have the first 5G workshop in 3GPP, where 3GPP thought about what 5G could be and how to tackle this. And then it took another 3 years, I already mentioned this, until we have seen the establishment of 6G-ACIA. And this is basically the start of a really stronger engagement of the industrial domain of the OT industry. Then we were quite fast, I would say. So later in 2018, 6G-ACIA became a 3GPP market representation partner for the industrial domain. So with this, we established strong ties with 3GPP. In 2019, we have seen the first complete 5G specifications, Release 15. Of course, the early drop was already there in 2018, but the full release then in 2019. But the focus was still on the consumer business, on consumer 5G. But at that time, we then prepared quite a number of contributions And we did a lot of work in 6G-ACIA to support developments towards industrial 5G. So we have extensively analyzed use cases and requirements and communicated them to bodies like VGPP. We've put together channel and traffic models because also here the industrial domain is very special. We have done quite some work on time-sensitive networking, what needs to be supported here, non-public networks, different deployment concepts, for example, and so on. So then really the activities took off and started. In 2020, we have then seen in summer last year that Release 16 has been completed. And for the first time, there was a very strong focus on the industrial IoT, picking up many of this work that we have done and driven also out of 6G-ACIA. So and where are we today? So we are now waiting for Release 16 to see the first chipsets, infrastructure components, and so on. And from my perspective, this will mark the beginning of a more widespread adoption of industrial 5G, but there's still some work to be done. I mentioned this before. And topics we are working already on in 6G-ACIA and that we still have on the roadmap. So it's about coming up with device profiles for industrial 5G devices, certification aspects, the integration with other technologies like OPC-UA, which is the standard middleware solution for the industrial domain, test beds and validation as an important building block, reference architectures, and of course also future features to support even more use cases and applications in manufacturing. But if you look at this again, this is what I mentioned before, so that the industrial domain started a bit later than the ICT industry. So this is quite clear if you look at this slide. So basically from 2012, there was a very strong engagement of the ICT industry. But only 6 years later, basically the industrial domain started to get engaged. So we've been working on this for 3 years now. And that's simply because it's still one reason why it still takes a bit more time to unlock the full potential of industrial 5G. Now, this is the 6G-Symposium, of course. So therefore, I also would like to talk a little bit about the further evolution of 5G towards beyond 5G and at some point also 6G. We recently had some discussions about this also in 6G-ACIA, and I would like to highlight 10 aspects basically that we consider as important for the further development of industrial 5G. And first of all, and I guess this is not very surprising, is that 6G or whatever comes after 5G still should have a very strong focus on vertical industries from day one. That means this direct engagement of verticals is very important. We have seen the focus on vertical industries also with 5G, but as I've shown on the previous slide, the real integration of the verticals started only later. For the further evolution, this should be different. And this, of course, applies not only to the industrial domain, but also to all the other domains. Secondly, and that's a little bit related to this, of course, we should continue working on new ways for using mobile technology. And here, non-public networks certainly play an important role. So I called it here non-public networks 2.0, so that we strengthen the non-public networks and support maybe additional deployment and operating models. Because many applications, again, in manufacturing, but also in other domains, are really local applications. And therefore, these local networks are good enough, basically, to support them. We have special requirements in the industrial domain. For example, it's security reasons that which drove these developments towards non-public networks. It's also business reasons, of course, questions about accountability and so on. And we really should put this into the focus also for the further development of 5G. Then sophisticated self-management is an important topic. So it's not primarily enhancements of the user plane, but there's a lot of potential to unlock also on the management plane and control plane. Using, of course, artificial intelligence and machine learning to automate things, to simplify the operation of such networks, for example, but also to deal with quite dynamic environments. A factory, for example, it's a very controlled environment in some way, in a local environment, but especially with the vision of the factory of the future, it could also be a very dynamic environment, so that we reconfigure the production on a very short time scale. And of course, if we change the layout of a factory, we do not necessarily want to do a radial planning again manually every time. So there should be ways to automate this and to have the network automatically adapt to this. And AI ML certainly may play very important roles in this respect. Then backwards compatibility. This is a really an important topic, and I briefly mentioned this before already. So manufacturing, production machines, production lines are really used for a long time, 10, 15, 20, or even more years. And that means we should make sure that whatever comes up after 5G should be backwards compatible in order to make sure that the investments that we make today are not lost and are not gone, but that we can still build upon the investments in future. So therefore, it should not be completely revolutionary, but more evolutionary in some respect. Flexibility, modularity is also very important. Of course, there is the industrial domain. You could say we need a solution for the industrial domain, but even the industrial domain is very diverse and heterogeneous. There's a process industry, there is discrete manufacturing, there is a car production, there is semiconductor manufacturing, there's electronics manufacturing, and these are quite different kinds of manufacturing with also different needs and different layouts of a factory and so on. And there should be the possibility to easily support also these different types of manufacturing facilities. And of course, what could help is a high flexibility and modularity of the equipment, for example, that is being used, so that we can always pick the best solution for the concrete purposes and needs. Of course, even though personally I don't consider this as the most relevant aspect, but still there is also the need for advanced quality of service support to drive the capabilities of 5G even further. Of course, there are use cases where we could make use of even lower latencies, maybe below 1 millisecond, and maybe even a tighter synchronization. But of course, we always have to see what does it add in terms of complexity and cost, and what is really the benefit. Because if we can get the full 5G promises with 1 millisecond latency, this very high reliability, we can already do many things. And it's then more, as I mentioned before, maybe first of all about optimizing the management plane, the control plane, and so on. Something that certainly is very relevant here is positioning. So knowing where things are is always a very valuable information in a factory. And if we can manage, for example, to bring the accuracy, the positioning accuracy down to the centimeter level or even sub-centimeter level, so then that would be very interesting, because then there are many more things that we could do with it also in a factory. Open interfaces and full virtualization is another topic. Of course, this is something that is already going on and happening today, that we have disaggregation, for example, of the radio access network, and that we have these developments towards full virtualization. And it's something that might be also quite interesting for the industrial domain. This goes hand in hand, of course, with this higher flexibility and modularity, so that we also can then easily integrate or more easily integrate 5G or 5G beyond 5G, 6G networks into existing environments, and simply have more possibilities to unlock. So Open RAN and similar developments certainly could be very interesting and are very interesting here as well. So what we see currently in the discussions beyond 5G towards 6G is then also going to higher spectrum, beyond millimeter wave spectrum, terahertz, and so on. And this goes hand in hand with additional functionalities that may be supported by the network. So I'm thinking about integrated sensing for imaging, radar, material inspection, and so on. And of course, there are many things that could be interesting and relevant to the industrial domain as well. So for quality inspection, quality control, maybe integrated radar to support the operation of automated guided vehicles on the shop floor and so on. So that's certainly something that is quite interesting, but also something that we still have to better understand. Sustainability and efficiency, and also here, I'm quite happy that also Paul brought this up in his presentation, and just to make sure, we haven't really aligned the presentations up front, but obviously very well aligned views here. It's something that also 6G-ACIA considers to be very important, to make sure that, for example, energy efficiency is increased, and not just the efficiency then of the communication equipment, but of the entire solution. Of course, we can also use 5G, beyond 5G, and later 6G to achieve higher levels of automation and so on, to improve the energy efficiency and sustainability basically of a factory. And it's something we should also have more in the focus for the future developments. And last but not least, I think what we also should think about is how can we make it even simpler and easier for vertical industries to get directly engaged into standardization and relevant regulation processes. 6GSymposium has been established in order to support this and to provide a shortcut for especially the OT industry towards 3GPP and other organizations, but it's still very difficult and very time consuming basically for companies to directly engage with 3GPP, for instance. And if you then look at the structure, for example, of the industrial domain, of course, there are some big players, but there are also many small and medium-sized companies. And for them, it's simply too much effort and too time-consuming to get directly engaged. And whatever we can do in order to simplify this and to support, especially also these smaller companies, to make themselves better heard, so that would be very much appreciated and something we can think about. All right. With that, I'm coming already to the last slide. So this is just in case you would like to learn more about 5G in the industrial domain and the work that we are doing in 6GSymposium. Would like to invite you to visit our website, 5G-ACIA.org. There you can also download a number of free white papers that we've published so far. And there is, of course, more exciting information to come soon and to be published soon. I would like to invite everybody to join us to make sure that we jointly unlock the full potential of industrial 5G in the first step, but then later on also the further evolution towards beyond 5G and 6G in future. So with that, I'm at the end of my presentation. Thank you very much for the kind attention. Thanks again, Alex, for the kind invitation, and I would be happy to take any questions now.
Thanks very much, Andreas. So we have time for a couple of questions, and I'm going to start with one from the audience. Now, this one is from Frank Formis, and he's asking, it would be great to see a real business case for industrial 5G and to understand where the demand is coming from on that. So I wonder if you can sort of share some perspectives from that industrial side as to whether there are particular use cases that are driving this interest in 5G at the moment.
Yeah, of course. I mean, there are the usual suspects, I mean, with a lot of interest. But before I deep dive a little bit into this, I think it's important, again, to understand there is not something like a standard factory. It's really very diverse. That means everybody has to check for his or her own factory, basically, what the potential is and how things can be done in a better way with 5G. But the usual suspects are basically those use cases where wireless per se makes a lot of sense. That means if you want to connect mobile or portable devices, mentioned automated guided vehicles, there can also be smart tools, wearable devices, augmented reality glasses, and so on. So there you need wireless, and especially for many industrial applications, you have still very demanding requirements in terms of availability and so on. So therefore, these are the use cases that are often considered. And also then if it's about retrofitting, for example, right? We have this long lifetimes of the machines, but still there are new capabilities, for example, thanks to artificial intelligence and so on. And if you can easily upgrade existing machines by putting some sensors here and there without having to worry about cabling and so on, of course, this can also provide immediate value. And these are also some of the low-hanging fruits, basically, that I would see here. But at the end of the day, it really requires a careful calculation. What is the value add and what are the additional costs? And also on the cost side, of course, the entire ecosystem still has to find a sweet spot. It's a new market for everyone. Everybody tries maybe to get most out of the market, but we have to meet somewhere in the middle in order to make sure that it's attractive enough. But personally, I'm very much convinced that we will see more widespread adoption of 5G manufacturing pretty soon.
Brilliant, thanks. And one more question. You've talked a little bit about the role of 6G-ACIA in the development of new standards with 3GPP and so on. So I'd be interested to know what role you're playing at the moment and what changes you'd hope to see in order to get a stronger or at least a different voice for industry in the standards development process.
Yeah, I mean, the role really is to bring all relevant stakeholders together with a clear focus on the manufacturing industry. I think that's a major difference compared to 3GPP, for example, right? If you go to a 3GPP meeting, and be it SA1, which still has a very strong focus on use cases requirements, but then there are meetings where you're not just discussing about manufacturing, but about trains and about agriculture and so on. And it means many things are not really relevant to the OT side of 5G-ACIA. For the ICT industry, maybe everything is important because you want to serve all the different verticals, but not so much for the OT side. So in 5G-ACIA, we have a strong focus just on these discussions, and we also have a holistic view on this. So we are discussing also things which go beyond the scope of UGBP, right? So recently we signed an MOU, for example, with the OPC Foundation, which has a very strong role towards OPC-UA, which I mentioned before, and similar solutions. We are closely aligned with other initiatives, the IEC, for example, which is very relevant to the OT side. And it's really then having this holistic view to make sure that all the different building blocks at the end of the day fit very well together. And I think we already did quite some good progress in understanding each other and finding a good mode of collaboration and so on. But as I mentioned before, still, it's quite some effort, especially for the OT side. I mean, to directly get engaged in TGP, but even in 5G-ACIA. And here we always have to be aware of the fact that for the industrial players, 5G and later on 6G is typically not a core business. It's just one building block apart from many other building blocks that they have to consider. But that's one of the reasons why they cannot spend so much effort like maybe the ICT industry does. And so efficiency in the way of collaboration is really a key challenge always.
Great, thanks, Andreas. Now there are quite a few more questions that have come in, which I don't think we're going to be able to address live. Perhaps we can take those offline. But yes, as I say, we're coming up to time. I hope that you in the audience are going to be able to join our next session, which takes a deep dive into what 6G is and isn't. So we'll leave you with enough time for a quick comfort break before that starts. It only remains for me to thank Andreas and Paul, as well as you, the audience. And remember, if you want to revisit any of the insights and sessions from the 6G Symposium, the videos should be available from next week. And by all means, feel free to get in touch with us at 6G World. We'd love to hear what you're doing and what's on your mind. So thank you. Goodbye for now.